For homework tonight, please complete page 7 and correct it with this section. First, you're going to make a line plot displaying the foot lengths of the female students. Make sure you only pull out the female student values. So I'm going to go ahead and circle those first. And that gives me a chance to think about the range of values that I'm going to need to fit. So I can see, for example, that I have values from 20 all the way up to, let's see here, 25. So for my range, perhaps I'm going to go 20, 21, 22, 23, 24, 25. You can even go further if I want. And now I'm going to plot in the different dots, right? So I can see I have a 20, I have a 25, I have a 23, 23.5, two 24s, and then I have, let's see, a 23 and a 25. So 23 and 25. So that's my dot plot. Next, I'm asked to find the mean of the female foot length data. If I add up all the data values, I get a sum of 187.5. And then I have to think about how many data values I had. I have 1, 2, 3, 4, 5, 6, 7, 8 values. So I'm going to divide 187.5 by 8. And that leads me to a mean of 23 4/10 approximately. So I can even mark that in here. It's a little less than 23.5. That would be my mean. Now I'm going to find the MAD of the female foot length data. So again, this will take a little bit of time. I need to compare each of my values to the mean. So I'm going to compare 23.4 and subtract 20, and I get a difference of 3 4/10. I'm going to compare 23.4 and 23, and so then I get a difference of 4/10. And I have two of those here, right? So I'm going to make sure that when I add these, I'm going to include two of those for my two 23s. Then I have 23.5. So 23.5 minus 23.4, I now have 1/10. And I keep going, so now 24 minus 23 4/10 gives me 6/10. And again, I have two 24s, so I'm going to have two 6/10 to add in there. And then lastly, I have 25. And 25 minus 23 4/10 is going to give me 1 6/10. So I'm also going to be adding 1 6/10 twice because I have two of those data values. So now let's go ahead and add up and find the sum of all of those differences. And I get a sum of 8 7/10. And again, I'm going to divide by the number of data values, so I have a total of 8 values. So 8 7/10 divided by 8 would give me about 1 1/10. It's 1.0875. I'm going to say that's about 1 1/10. So that's going to be my MAD. So here's my MAD, here's my mean. Now I'm going to mark the location of one MAD and two MADs less than and greater than the mean. So I'm looking at 23, where my mean is 23 4/10. If I add 1 1/10, I'm going to get to 24 5/10. So 24 1/2. So that's going to be right here. So again, this is my mean. This is one MAD above. And then if I took 24 1/2 and I added another 1 1/10, I would get to 25 6/10. So I'm going to mark that here as well. And so now I've gone two MADs above the mean. I'm now going to go two MADs below the mean. So I'm going to go below, I have 23 4/10, and I'm going to subtract 1 1/10. So that will get me to 22 3/10. It's right around here. And then I'm going to subtract 1 1/10 one more time. So again, I'm at 22 3/10. I'm going to subtract 1 1/10, so I'll get to 22, or I'm sorry, I was at 23 4/10 originally. I subtracted 1 1/10, so I got to 22 3/10. And subtracting another, I'll get to 21 2/10. Let's say about here. All right, so you can see that these are about spread apart. Now we're going to do the same thing for the male foot lengths. Now let's make a line plot displaying the foot lengths of the male students. So first I'm going to note which values went with the male students. And I can see that I have 6 of them. And they range from 15 all the way up to 23. So I'm just going to go by ones here. 15, 16, 17, 18, 19, 20, 21, 22, 23. I have 1 15, 123, I have 3 20s and a 21. All right, so now we're going to find the mean of the male foot length data. So let's go ahead and add them up and find their sum. We're going to get a sum of 119. And note, we have how many values? We have 6 values, so we're going to divide by 6. And then at this point, we can find our mean of 19 and 8/10. So I'm going to go ahead and mark that in with a triangle, 19 and 8/10. And now let's find the MAD of the male foot length data. So let's write out all of our values. So 15, we have 3 20s, 21, and 23. And we're going to find the difference between the mean and each of those values. So 19 and 8/10 minus 15 would give me 4 and 8/10. 20 minus 19 and 8/10 would give me 2/10. In fact, I'm going to get the same thing for each of these since the values repeated. 21 minus 19 and 8/10 is going to give me 1 and 2/10, and 23 minus 19 and 8/10 is going to give me 3 and 2/10. So now let's go ahead and find that sum. So 4 and 8/10 plus 2/10 3 times, plus 1 and 2/10 plus 3 and 2/10. This gives me a sum of 9.8, and if I divide by 6 for my number of data values, I get 1 and 6/10. So now let's go ahead and mark in 1 and 2 MADs above and below the mean. So if I take the mean again, 19 and 8/10, I'm going to add 1 and 6/10, and that will give me a total of 21 and 4/10. So I'm going to go ahead and plot that on here and put a line for the mean as well. And then I'm going to add another 1 and 6/10 to get 2 MADs above. So that will get me to 23. So I'm going to go ahead and mark that here. Again, remember that numbers that are on the line don't include or don't count as being within 2 MADs, or in this case. And now we're going to do below the mean. So 19 and 8/10 as the mean, and we're going to subtract 1 MAD, so subtract 1 and 6/10. That'll get me to 18 and 2/10. And then we're going to go down another MAD, so subtract another 1 and 6/10. And we're going to see what we have. 16 and 6/10. So right over here, about. And so looking at those and how they're kind of spread out, we can then start to make some other conclusions about our data set. So now we're going to mark the male foot length, the mean male foot length, on the female foot lengths. And so again, I kind of took a screenshot earlier. So the male foot length was around 19 and 8/10. So it's going to be a little bit off of what I have right here. And then I'm going to think about, is the mean male foot length an unexpected data value for the female line plot? Well, do you remember today in class we talked about how if the data values are within 2 MADs of the mean, then it's within what we call the normal distribution. And so if I look at what's here, I'm noticing that the mean for the male students is outside of the normal distribution for the female students. So in this case, I'm going to say, yes, it's an unexpected value. And this has to do with it being outside, right? It's outside the normal distribution. Now, that does not mean it couldn't happen. It just means that it's less likely to happen. And now we're going to go the opposite direction. So we're going to mark the female mean foot length. So I'm going to do this in green here. So it's around 23 and a bit more, around 23 and 4/10. I'm going to mark that on the male. So 23 and 4/10 would be all the way up here. Actually, a little bit less than that, 23 and 4/10, because it's going by ones. And so again, I'm going to think about the same question. Is the mean female foot length an unexpected data value for the male line plot? So again, looking here, this would be within 1 and then 2 MADs, right? This is within 1 MAD on either side, and then extending out another MAD. And so looking at this, I'm noticing that the female mean is also outside of the 2 MADs. And so again, I'm going to talk about how, yes, it's an unexpected value. And again, I'm really connecting it to the fact that it's outside the normal distribution. So in other words, it's within 3 mads of the mean instead of within 2 mads of the mean. All right, that's it for today. We will see you tomorrow for a cookie simulation.